For those of you who've already experienced reciprocal functions, you can skip over this very quickly. Skip over the first part of this lesson very quickly, and then we will do these other ones. We're going to introduce new concepts of Pythagorean identities. But first we have to start with the inverse or the reciprocal trigonometric function. When you hear the concept of a reciprocal, we're actually talking about flipping it. So for example, if I took the reciprocal of 3 over 4, I'm going to get 4 over 3. That's all I mean. So the reciprocal functions for each of the basic trig identities, sine, cos, and tan, are cosecant x, which is 1 over sine of x. Then we have sec of x, which is 1 over cosine x, and cotan of x equaling 1 over tan of x. Now, there are two other identities that we need to understand. We have tan of x, which is, well, it's sine x over cosine x. And these are the basic reciprocal identities that we need. So if you think of tan x being sine x over cos x, then cotan of x is literally going to be this. Could also be written as cos over sine. All right. So now let's move on to the Pythagorean identities. So these are some Pythagorean identities that I want you to learn about today. And they all start with sine of x squared plus cos of x squared is equal. So I apologize for saying it wrong. It's sine squared x plus cos squared x is equal to 1. So there are two other identities that we can come up with based on this. So one, you're actually going to divide everything by sine squared x. So you're going to div by sine squared x, and you're going to get something that looks like this. Now, in doing so, you have some cancellation. This goes away, and then this part here turns into cotan squared x. And this last part here turns into cosecant squared x. So we're left with this. And we have 1 plus cotan squared x is equal to cosecant squared x. The next kind of calculation we can do is we can divide everything by cos squared x. Div. Now, in doing so, you're going to get something that looks like. And by dividing by cos squared x, we have some interesting things happen. Again, this time we have sine squared x over cos squared x, which is really sine over cos all squared, which is really just tan squared x. And then cos minus cos is just cos divided by cos is 1, and then this turns into secant squared x. And so our last trigonometric identity is tan squared x plus 1 is equal to secant squared x. Now these three can be used to help us find answers to many problems. Let's go over them. So when you see a problem in your textbook or on any university texts, they'll say evaluate, otherwise known as find the answer. So they're asking us to find cosecant of negative 3 pi over 2. Now, the question is, where the heck does that come from? This comes from this following concept. So imagine you have your initial arm here, and you're going back 3 pi over 2 radians back, okay? Now, in order to calculate this, you'll notice that on the unit circle, this is the point 0, 1. Okay? Now, based on that, you could literally just come up with the answer here. Remember that on the unit circle, x and y and r are calculated by its positions, right? Now, cosecant, you got to remember, is just 1 over sine, right? And 1 over sine is just h over r, also no, sorry, h over y. And in this case, when we have our terminal arm on this edge here, that means we have r over y. And the r value is equal to 1. And the y value of our point also equals 1. So therefore, our answer is 1. So that first one is using geometry to find our answer. But let's say we didn't have that. This is what we would do as an aside. And you weren't sure what to do, just brute force it. So you know sine of negative 3 pi over 2 is the same as 1 over cosecant. So that's where we have this equation here. So here's the next part. Based on the concept that sine of a negative number is the same as negative sine of the number, then this becomes negative sine of 3 pi over 2. And sine of 3 pi over 2 is just 1 over the negative of positive 1. The negative of negative 1, which gives us 1. And this is what I call the brute force method. Now, the reason why this is true is because we know that sine is an odd function. Okay? So suppose we have tan of negative 5 pi over 6. Well, you know that tan is just the opposite over the adjacent. And in our triangle, the opposite is the y value, and the adjacent is the x value. So this means we have y over x. Now, here's the next aside we have to think about. Because this has something over 6, we have something over 6, right? It means that we have something that has to deal with that cool little triangle that has a pi over 6 in it and a pi over 3 in it. So this is 2 and 1, and then this is root 3. So in that little right triangle, we have that. So let's go and figure out what that would look like on our graph. So you start with this. You go and start with your initial arm, and we have to go negative 5/6 this way, right? So if I go negative 5/6 this way, negative 5 pi over 6, that means that inside this angle here is an acute angle of pi over 6. And remember, in our cast rule, we know that tangent is only positive in this angle triangle, in this angle. So I'm going to zoom in on here and start drawing some stuff. So I'm going to erase this, and then we're going to fill this in with our little triangle. So if we zoom in on this triangle that is created here, I'm going to draw it in blue. So I have my triangle here and here, with my angle here being pi over 6. Now, if I have pi over 6 here, the opposite angle is going to be -1, because it went down -1, and going across the x-axis here, this is going to be -√3. Okay, so the distance going back from that origin is -√3, and going down is -1, which means that our final answer for everything that we were studying just now, we just substitute into our solution. So we have equals, our y value is -1, and then we have -√3 for x, and our answer is 1 over the square root of 3, and we're done. So now let me just zoom out and give you access to the entire problem so you can kind of see where we came up with all these ideas. Okay, so remember, this part here is kind of an aside to kind of give you an idea of where we're getting all these numbers. The main idea of this topic is to work on this portion of the work by using geometry and then using your knowledge of your right triangle trigonometry. Okay? All right, so now let's move on to our... All right, so now we have a problem where I give you a ratio, and this here is my ratio. Now, my question for you is, can you find the other ratios for, say, tan, cos, secant, sine, secant, cotangent, and cosecant, CSC? Can you find all those different ratios? Now, we're going to go through every single one, but the first thing that we have to do is, based on this original triangle, this original ratio, you got to remember this. As an aside, you know that cotan of x is equal to 1 over tan x, isn't it? Which is really just cotan of x, which is equal to, sorry, not cotan of x, which really means tan of x is equal to 1 over cotan of x. Now, 1 over 1/2 gives us 2. So tan of x is equal to 2. So that is our first ratio. Okay? Now, based on that, so tan of x is equal to 2. So now let's go and try this next one. Let's use one of our calculations before. So you know that 1 plus cotan squared x, which is one of our Pythagoras theorem problem identities, is equal to cosecant squared x. So we have the following: 1 plus 1 over 2 squared is cosecant squared x. This turns into 1 over 4 plus 1 cosecant squared x. So cosecant squared x is equal to 5 over 4. Now, to get this by itself, we got to square root it. So cosecant x is equal to plus or minus the square root of 5 divided by the square root of 4, which is 2. Now, based on this solution here, I'm going to tell you that I can figure out exactly where this needs to be. So cosecant needs to be between here, it needs to be between pi and 3/2. So that means it's in this quadrant, okay? So now cosecant should be negative. So that means my answer for cosecant is going to be x is going to be negative root 5/2. And since cosecant is 1 over sine, that means we just say the following to basically kill two birds with one stone. We have sine of x is going to equal negative 2 over the root of 5, for which we have to get rid of that radical on the bottom. So we multiply the top and bottom by root 5, which gives us a final answer of negative 2 root 5/5 as my final answer for sine of x. So now we have sine of x. So now all we have left to do is to compute cosine of x. Now, to compute cosine of x, we can use an alternate form of the Pythagorean identity. All right, so remember that we originally had cos squared x plus sine squared x is equal to 1. Well, you know that if you solve this for cos squared x, it's going to be 1 minus sine squared x, isn't it? Which gives us 1 minus bracket negative 2 root 5/5 all squared, and that's what cos squared x is. So we have 1 minus negative 2 root 5 multiplied through, you're going to get 1 minus, well, 2 times 2 is 4 times 5, which is 20 over 25, which gives us, when you simplify, you're ending up with 1/5. So that's cos squared x is equal to that. So now to get cos by itself, all we have to do is square root. So cosine of x is equal to 1 over the square root of 5, which is really the square root of 5/5. And now all you're left to do is to calculate the ratio of secant x. Negative root of 5. And this should be negative root of 5. It should be a negative because it's in the proper quadrant there. And we're left with that. Now I'm going to put a copy of the last problem online, and then I want you to do the following questions. You're going to do 3 to 19 odd. Now, I'm not saying do every single question from 3 to 19. Get used to it and then move on. When you get to question 25, there's an extra problem called 27, which is a challenge. All right, get to work.